waiting for the last few people to join us. So we have a final presentation now from Frank Rothe, following the same theme as earlier, which is to do with technologies required to achieve the advanced emissions reductions, which we discussed earlier in the day. And then we'll move across to a slightly different theme for the final two presentations, which is more to do with monitoring vehicles in use. So let's first go back to the presentation from Frank Rothe. He's from TT Electronics, Product Application Manager, Pressure, Temperature and Fluid Property Sensors. And he's going to be telling us more about the latest in urea concentration sensor technology. We heard a few things about this from Stephen at KUS, but we're going to hear some more from Frank about their products, updates on latest market experience and how we meet future customer requirements. Frank has worked at AB Electronics since 1997. He's currently in his role, which involves focusing on a variety of automotive sensors, including fluid property sensors. Interestingly, I just read he worked in the 80s for the motor mechanics at the Army University of the GDR, where his theme for his thesis was soot measurements in diesel engines. So a long interest in diesel engine emissions.
Yes.
So someone who's really certainly taken this theme to heart. And so, Frank, over to you. We look forward to your updates on what can be done with urea concentration sensing.
Thank you, Tim. Thank you. Let's go down from big engines to systems, now breaking down further to components, to sensors. Hello, everybody. It's great pleasure to me to talk to you in this teacher conference again, and especially here in Dresden, because it's just 25 kilometers from our factory, so it's a home game for us, or especially for me, and therefore it's a great pleasure to be here. Today I would like to talk about, as Tim said, about the latest in urea concentration sensor technology. Formerly we used to name it at Blue Quality, but well, it's more or less urea concentration sensor. My speech is divided in just three parts. First, I want to talk about which technologies are available for urea concentration measurement and which technologies are leading at the market right now. Furthermore, I would like to talk about our experience we got from the field, from customers, from validation testings, and also from our development process. Finally, I would like to give you a short update in sensor solution from AB Electronics, which is part of TT Electronics. You might wonder about the difference between AB Electronics and TT Electronics. I used the name of AB Electronics to be the first in the attendees list. Anyway, looking to this global map, we see many colored countries, which means there's some emission regulation in charge. Generally speaking, in order to survive, global emission of greenhouse gases need to be reduced and therefore regulated. Currently, we face different legislation levels on different markets. This needs to be regulated or harmonized during next years, I would say. And always we talk about BS6 in India, which is related more or less to Euro 6. China 6 will come in several years. So all the other countries will also have to go this way. Global direction clearly goes to zero-emission vehicles, but it will take some further, I would say, decades of years before 100% of zero-emission vehicles will be sold to the market, especially in the car market. In the meantime, emission control and exhaust after-treatment systems need to be maintained and improved, as we heard all the day today. Especially on heavy-duty and off-road market, I don't see any real alternative to diesel engine right now. This slide shows, in principle, the exhaust after-treatment system of a diesel engine. TT Electronics, or AB Electronic, is well known as a sensor supplier to such systems like boost air and EGR temperature sensors, pressure sensors and temperature sensors to the exhaust line, and temperature and urea concentration sensor to SCR dosing system, high temp sensors, and finally this urea concentration sensor. Let's talk about SCR systems. Late in 2015, the so-called Dieselgate occurred, as already known. At that time, just Volkswagen was blamed to use forbidden software. But honestly, we all know that more or less every OEM who followed the plan to make SCR easy to use, that means no AdBlue refilling by drivers, all had to find a way to limit AdBlue consumption. But we saw that there's no way to fulfill this requirement on a legal way. In the meantime, we know that for full NOx reduction, between 5 or 7% of AdBlue consumption related to diesel consumption is needed, has to be considered. That means car drivers need to refill. So that means further that the system, the SCR system, is open. And it's open for contamination. So there I have identified 3 big points of where contamination could occur. First, contamination without driver's influence. I think most of the people attending to the AdBlue forum on Thursday will say, no, there's no way of contamination in this area. But we do not know, really. There are treats for failure to fill correctly. For example, a driver can use uncleaned diesel canisters, filling diesel into AdBlue. We saw, and this is a picture I made in the Agritechnica. This is a tractor. You see always diesel and DEF or AdBlue tank nearby. So this is also the case in cars. So, and this can lead to failures in filling. And last but not least, there's also a threat of contamination by drivers who want to cheat the system. You want to save money. This is what the legislation wants to avoid. And therefore, we need to monitor. And you don't need to read this slide. It's just should show an example what European legislation and US legislation is going to introduce if the system doesn't work or the onboard diagnostic shows some uncertainties. So, for example, vehicle speed could be reduced to 20 kilometers per hour if AdBlue level is below 2.5% in tank, or poor reagent means fluid quality was detected for more than 20 hours of operation, or improper dosing was detected for 20 hours or more. This could happen, and in order to introduce such systems, you need reliable sensors for quality, means urea concentration, level, as Stephen already said, and temperature. They are necessary to keep the world alive. How can urea concentration be monitored with the best cost-benefit ratio? Stephen from KUS already talked about different principles they are using. I have identified several systems or several physical principles which could be used in the ISO 22241, which is about AdBlue or DEF, diesel emission fluid. The urea concentration is clearly defined between 31.8 to 33.2%. And beside that, there's identified the related refractive index at a certain temperature, as well as density at a certain temperature. And those two physical principles of values are the mostly used values to determine the urea concentration. We already talked about, or Stephen already talked about, ultrasonic sensors, which measure the density of the fluid. There are some other principles in use, the thermal capacity, Stephen also mentioned, which is also on the market, thermal capacity or thermal conductivity, which is more or less, a double pass. There was, I would say, on the market some spectroscopy sensor, which is called near infrared, using the chemical characteristic of the fluid, and also some capacitive sensors could be on the market. But I've clearly identified that the mostly used sensors are thermal capacity, density, and last but not least, refractive index. And this is what we are using. Our sensor is quite easy. We use the physical principle of a refractive angle, which is resulted in a certain refractive index, which was determined by urea concentration. And you see on the left side how it works. We have a LED creating a light spot, and this light spot goes through a prism. This prism contains of the fluid. And on two positions, the light is changing, the light direction is changing according to the refractive index. And finally, we have a certain resulting, a resulting position on a photo sensor or CMOS line sensor. Here you see this picture, how it is in reality. You are welcome to visit our booth over there in the cafe area, where you can see the sensors in practice. This is in principle what the oscillograph shows. We have this CMOS line, which is in real life is 8 millimeters long. And we clearly can identify water, which has a refractive index of 1.333, compared to AdBlue, means 32.5% urea in water, 1.383. So we have a distance of 220 pixels, which means 0.15% resolution. And if you see this is engine oil, which can clearly identify it. The good thing is that the signal goes straight, so we have a linear signal from 0 to more or less 100%, or the refractive index, which could relate it to 100%. And we can clearly identify if we have water, if we have some other fluids like washer fluid, ethanol. We can identify real AdBlue, of course, gasoline, brake fluid, diesel. They are very far away from it. So in some cases, some customers wanted to have a signal coming from the sensor that we have diesel. Normally, we just have outside the area of proper AdBlue, our sensor mentioned wrong fluid, the signal. But some cases, we can also set a special information from the output signal, from the CAN bus signal can clearly determine diesel oil, for example. Coming to some parameters, our sensor is now we can provide different digital signals. We started with PWM, have in charge in production a SEND protocol, which is more related to car application. And we also we are producing sensors in series production with CAN bus signal. If you have been in the off-road section this morning, so you saw the C-Door presentation using our sensor as well. Coming to the accuracy, Stephen mentioned that our sensor has a 2% accuracy at a certain area, and outside this area 4%. And what I have to say is this is a real accuracy after life. You see this slide, this picture, this red line shows the accuracy area which is agreed with customers, and this is life end. And you see in the middle just 4 or 5 samples which we have measured in real, or if the part is new, we have plus minus 1% as well. But this is not what we are mentioned. So we mention end of life. So this is our principle. Maybe it is a disadvantage if you see other systems having 1%. I could say also we have 1% sensors. The sensor principle we are using gives us the possibility to be very flexible in the system. Our sensor is being used as a on-tank sensor, means standalone on the bottom of a tank. It can be used on the side of the tank as well, of course. Can be used as Cus does inside the tank. It can also be used on the top side of the tank sensor unit as well as inline, again, as some other customers do at the moment. So the main advantage is the measuring area we have, it's just 10 millimeters. And we just need to maintain AdBlue in this area, or DEF. And the rest is not ours, let's say. Here you see the picture of our first application we had with a car application. Sensor being used as a standalone sensor. Together with a welding adapter, it's being welded on the tank. Again, as I said, we also have realized sensors with inline adapters. Just putting some adapters to the sensor. From prototype to series production, you might have seen this picture this morning as well from the sensor. And on the boot, I also have this kind of sensor to show in real. We also provide a sensor to inline or line manufacturer, supplier, and we had as a common system with integrated sensor as well. This is what you already have seen, or what you also can see outside on the boot of KUS, our sensor used in the tank sensor unit for heavy-duty truck application. And here you see this cover around the sensor, which maintains the sensor under frozen condition as well as under bubble condition. And we also can integrate, as I said, to some other systems like a pump head or some other position on the system. So always probably working in different application, and what the best is, we don't have a big adaptation on the sensor. The sensor housing is always the same, as well as the principal, PCB and so on. Coming to some experience from the field, and coming back to Leonard's question, the influence of bubbles to the measuring system. What I can say is that due to the small area of the sensor, we have a very low impact or quite low impact of bubbles. I don't say there's no impact. There is some impact, but it's limited. Just to consider, light is 1 million times faster than sound, for example. And if you have small bubbles, like in this picture, there's no impact to the signal. If you have a certain position, you know the light is going through. On this position, there's no impact to the signal. And here, in this area, we see let's say, a bigger bubble. And of course, if you interrupt the light spot, then of course there is an impact to the sensor. And especially micro bubbles, they have no impact, definitely. This is more or less the same as it's seen on dust tests. It's also compared to microbubbles. There's no impact because as long as we have a certain target, you see here different levels of the signal. As long as we have a peak, and this is what Stephen also mentioned, up to 2.5 grams of dust, of Arizona dust in half a liter of solution, there's no impact to the signal. This is like going through a foggy condition with a car. Yeah? With a normal eyes, you don't see too much, but if you have a light on and you see the white stripes on the road, this is always seen. And this is more or less the principle. The sensor doesn't measure the intensity of the light, just the position. This is the main advantage of it. Just some minor advantage. Well, we use a flange adapter or a welding adapter. So that means, and we also had this agreement with the customer, that you can remove the sensor to empty the tank if some wrong filling was done. So what happens if you fill wrong fluid in the tank and you cannot remove it? So you have to mount off the whole tank. Coming to some freezing issues. So the sensor is positioned well on different positions, as I said. And here we have a picture of a winter testing with a real tractor. And the sensor was also built on the tank from downside. And in order to measure the power, the force to the sensors, we made a test with a tank. We got a real tank from customer, and we put it 4 sensors on and froze the whole tank. And well, of course, the tank is plastic tank. It can breathe, and it can well take over the volume increase. So the sensor on the tank wall is not impacted too much. And again, if we have mounted inside the tank, there's some cover around, or can be some cover around, or some freezing system, or some rubber, which can protect the sensor. Well, there's another problem we got from a customer response from window testing. It was a tractor, and a blue sensor, the concentration sensor, was on a position where it froze first and it melted last. So it took 5 hours at -20 degrees. So, and 5 hours is far too long for the legislation to get the system started. So that means also the sensor should give a signal. So for this application, we integrated a heating inside the sensor. So this white dot over there is, one side is a heat conductive pad for the temperature sensor, and also giving the energy from the heating. We have just 2 or 3 watt heating inside, and at minus 20 degrees, it takes about 20 minutes to melt the area around the sensor, just around the sensor. But having this system, here you see this, and on the inline sensor, we have integrated also a heating system. It's a PTC heating to melt the adapter. Having this freezing issue, there was another interesting effect we saw, and probably some of you have also seen it. If you make a freeze-defreeze test, you will see that there's some this mixing inside the tank. We saw that there's a special, different levels. Even if 32.5% is the eutectic point of AdBlue, there's a dismixing when freezing and melting. So that means if the sensor's on the bottom, we always saw that on a short time the signal goes up. It doesn't mean that the signal goes up, but the concentration goes up. And this is an interesting point. The sensor is not wrong. It's always the feedback from the customer coming from the test. Your sensor is wrong, but the sensor was not wrong. The sensor showed the real condition inside. And we made, here you see this, and this test was made just before full freezing, so there's no interruption in the signal, but we saw that at the area of, almost frozen, the concentration on a certain point went up a little bit. So, but the problem is the concentration goes up to more or less 37, 38, so outside the proper area. And again, this is not the problem of the sensor. We made our own measurements, and this is the same sensor, the same solution. One is the green points are just, let's say, fixed tank, and the red points were shaked tank. And when melting, you see we have a certain signal. It's about 33%. And then if you shake the tank, that means if you mix it, then after a short time it goes to a normal level. If you have it fixed, the level is kept off on the upper side. So just one question, who saw the same effect in testing of you? Did you get this effect somewhere? No? Surprising. Because this is always a feedback from the field. Last week I got from another customer, another interesting response, because he said after the signal from the sensor started again after freezing, because we have a freezing point where the sensor turns off. Let's say we have an ice bit. So the software says, stop, there's no signal. Just after restarting the sensor, they saw that the concentration was down 28%. And after a certain time of shaking, the signal came up. But again, it's not the signal, it's the solution. The sensor gives the information, like our tongue, our eyes get the information, but decision has to make in the brain. So this is maybe a point to discuss. Well, urea concentration temperature and tank level monitoring are mandatory for well-controlled SCR system. Okay, our sensor is able to be integrated, as we said, to tank sensor units together with level sensors. Our sensor can handle the CAN signal. As I said, our sensor can give the CAN bus signal and can also get the signal from temperature sensor as well as from level sensor and can handle this. And we also have on our roadmap combined integrated combination between with temperature, sophisticated level sensor, and urea concentration. This is just, some pictures from our development stage. Okay, give me just some seconds to talk about our whole sensor portfolio, our whole competence. As you see on this slide and also as you see on the booth outside, we have a wide portfolio on different sensors. Not just pressure sensors, temperature sensors, fluid property. We also have a wide range on position sensors in portfolio. We have speed sensors and also control units. For example, control unit for electrical water pump, electrical oil pump, and such things. And last but not least, high temperature sensors. And we have a lot of different temperature sensors, for example, in EGR systems, heavy duty, light duty application, very robust in harsh application, harsh environments. We supply differential pressure sensors for DPF, GPF, and GPF is the right word to come over to our high temperature sensor. We have dual temperature sensors for GPF, means gasoline particulate filter, for the new coming Euro 6C, which limit the number of particles. So that means also gasoline engines may have problems or may need to introduce a gasoline particulate filter. And also for thermal management, we have created high temperature sensors with thermocouples. Okay. 0, that's it. Your question.
Thank you, Frank. We have time for 1 or 2 questions, not too long, but let's take 1 or 2 questions from the audience and the gallery up the top. Any questions from anyone about this sensor? Let me start with the same question I asked Stephen. Where do you see the main interest for this quality sensor currently? Is it in cars, non-road, commercial vehicles? Where's the application being found so far? And which regions?
Well, if we talk about volumes, of course, in car application, we see most interest, but you cannot say this is more or this is more. It depends on the legislation the customers want to follow and expect to get in the next future.
Yeah.
So I haven't seen any written legislation requiring a blue quality sensor. It's just the OEM has to make sure that we have the right fluid in, or you have a proper SCR dosing. So you need to make sure. So OBD regulation doesn't say you need to have a quality sensor or urea concentration sensor, but you can use it. Yeah. So and this depends on the philosophy of the OEM, how to handle this.
So currently speaking, it's the benefits of the sensor that drives the decision rather than the regulation driving the decision.
Yeah.
Okay.
Definitely.
Let's have a question in the middle. Alex, thanks. Lennart's hands up. Thank you.
Regarding that you haven't seen a regulation that requires the use of a specific sensor, I sure hope you will never see such a regulation. The regulation should ask about features, and then the OEM should make the choice of the sensor.
You mean it depends on the features of the sensor if you use?
No, the regulation should detect what kind of detection capability you should have. And then it's up to us to decide what sensor to use.
right?
Yeah.
The exception being China 6 last draft, but I sure hope that that goes away.
Yeah,
Yeah, regulations are generally technology neutral, or should be.
It should be technology neutral.
Yeah.
And I don't think you have seen a regulation require us to use SCR, but we are using SCR. And
Right.
I don't think you have seen a regulation that requires us to use a particulate filter,
yeah,
but we are using it. It depends on the level of emission that you need to cope with. And the same is true for diagnostics. It should be about diagnostic capability.
Yeah.
And then we pick the sensors.
okay, yeah.
Yeah, agreed. We should move on. Frank, thank you very much. It's always good to get the update. Thank you.